All right, guys, welcome back to um, our 5.7, which is the ambiguous case for the law of signs. I had my slides mixed up there for a second, and our think slash warm up is just going to be recall the law of signs, just so we don't forget it. Right? The law of signs says that A all over the sine of A is the same thing as B all over the sine of B, and C is over the sine of C. Doesn't have too much to do with what we're doing today in particular, but it's good to keep these things in the back of our mind where the lowercase a, b, and c are what's across from their big angles a, b, and c, capital A, B, and C. And so to start today, we have, if you have the measures of the two sides and a not included angle, there might be more than one unique triangle. And when I say that fast, it's kind of like, wait, what? But let's think about it here. If we have two sides and a not included angle, so in this case, we have this red side, and let's say this single blue side, and we have this not included angle right there, that green angle right there, that's not included, right? So it's not in between them. Do you see how with the same length blue side, we can create two different triangles? We have this smaller obtuse one, and then we have this one that's more like huge right here, right? Two totally different triangles we can make with that same blue length side. And so what this is going to lead to is that when we're given those properties, when we're given two sides of a triangle, and a non-included side, there's actually three possibilities. And one is that no triangle exists at all, right? The other one is exactly one triangle exists, kind of like what we've been working with. But then there's a possibility of what we just saw right here of there's two possible triangles. So let's talk about this. And this is what's in your book. And I think it illustrates it nicer than I could. So that's why I just put what was in your book up here. And so we have case one where we have our not included angle is less than 90 degrees. And then we just go into each case here, right? If we have the across angle A is less than the adjacent angle B, then there's three separate cases. A is less than B sine of A. In that case, this side isn't ever going to be able to hit this ground, so we have no solution. And then if A equals B sine of the A, then it's only going to hit exactly. But if we were to lift this up at all in any direction, swing it in any direction, we wouldn't be connecting anymore. So that's why it's only one solution. And then if we have A is greater than B times the sine of A, then there's going to be two possible things it could be, just like we looked at here. So those are three options there. So that one takes a little bit of deciphering. But then here, if we have A is greater than or equal to B, then it's automatically one solution. And for our second case, where our non-included angle is bigger than 90 degrees, a lot simpler. If A is less than or equal to B, then wherever we swing this, we can't connect it here. So that is going to be no solution. And then likewise, then we'll have A is greater than B, and there's always going to be one solution for that one. And for all that, I've made a nice table for you to either copy down, or I can make it as a material on Google Classroom so you can print it out. But this is essentially what I'm going to follow to do our first example, which we're going to get into. So determine, and again, pause the video here, and I'll scroll down just a little bit, pause the video, and write this down if you feel necessary. You can see how much work I did putting those all together, yeah? Go away. Well, you guys pause that. I'm not going to worry about that right now. So example 1, determine the number of possible solutions for each triangle. So I have made myself a nice printout. If you have your notes, you can just follow this thing along. And first thing is we have A, and I just like to sketch the triangle to make sure I know what I'm doing. We have A is 30 degrees, and A would be a cross from A. And if I said this is B and C, then we have B equals 10. And that gives us two sides at a non-included angle. And so now we just follow this. And we have, is A less than 90 degrees? Yes. So we're going to follow down this path. The A is less than 90 degree path. And then is A less than B? In this case, A is less than B, so we're going to continue down this longer path. And now we're faced with a lot of things. So we need to find what B sine of A is. So B sine of A is 10 times the sine of 30 degrees. We don't need a calculator for this. The sine of 30, maybe if we've gotten some practice with it or the unit circle, we can recognize sine of 30 as 1/2. So it's really just 10 times a half, which is 5, right? And so it's asking is A, which is 8. I shouldn't write that yet. And then it's asking is A less than, equal to, or greater than 5, and A is 8, and A is greater than 5. So we're going to follow that path, A being greater than B sine of A. And so that means we have 2 solutions. And that's all this problem is asking for, is how many solutions are there. Now this one, same thing. I see we have a 118 degree angle, so I'm automatically going to make one a little bit bigger than 90 and just connect it back. I don't really care about the rest. And that should be B, our 118 degrees. And then if I said this was A and C, it doesn't matter. And we're given C, which is 10 across from C, and little b is 8, and that can just be called A. And now, just because we have B equals 118 degrees, and on our sheet we're talking with A's, that means nothing, right? B is still our non-included angle, so we just treat it like A in our little flow chart. So we have B is 118 degrees, so B is greater than 90 degrees. So we're going to follow this right side flow chart, which is this side, which is a much nicer side to work with. And then it simply is A less than B or is A greater than B? And what we have to keep in mind there is B, our A is now B and our B is now C, right? We're matching this with that. So it's asking is 8 less than or equal to or greater than C, which is 10. And it turns out it's less than or equal to. And so it turns out we have no solution. And that, I think, is where we're going to call it for this one. The next one we'll pick up an example of solving the triangles after we figure out how many solutions there are to a triangle.